Oh, sorry, sir, I was muted. I'll say it again, 1 minute.
Yes, yes.
How does the water kept in the earthen pot become cool during summer?
How does a water cap in earthen pot become cool in summer? Right. So this is also the concept of same concept through which all the
Sir,
question
I
you
can't
have.
hear you.
Am I audible clearly? Am I audible, Rebecca?
Sir, I can't hear you still.
Am I audible?
Okay, yeah.
Okay. So this is also the answer of this question can also be answered in terms of evaporation. Evaporation. So basically, what happens when you have an earthen pot? Just take it this example. There are a small pores, a small pores. So what happens here? Basically, due to latent heat, what will happen with the help of this pores and surroundings, the small portion basically sorry through the small pores the water will be evaporated, and you know when evaporation will take place so it what will happen, it absorb energy from surrounding and makes it cool. Are you getting my point? In the same way that you did other question.
Yes, sir. I
So we
understood.
can write in the way water capped inside the earthen pot keeps evaporating through the pores and takes away the latent heat. Due to this process, the earthen pot will have cold water in summer. Is that clear?
Yes, sir.
Okay, so basically today we are going to start a new chapter, and that is matter around us pure? Is matter around us pure? So whether the matter around us is pure or impure, we are going to talk about this. If I'm going to say some of the example, let's take an example of salt. What do you think? Salt is pure or impure? What it is?
Salt
Yes,
is pure.
it's pure. And when you are going to talk about milk that we get in pocket, uh, that is also pure. So basically, what is pure and impure? First, we are going to talk about the mixture. What is mixture? What do you think a mixture is? How do you
It
define mixture?
Mixtures when there's more than one type of substance mixed together, or yeah.
Is the substance that are mixing in a fixed proportion, or you can mix in any proportion? What do you think?
Hmm. It can't be mixed by the same. It depends on the
Eh,
proportion, meaning when it's with
No, no,
salt
no.
and
Say. Let's take an example of lemon tea. What do you think? Lemon tea mm, is a mixture? Yes or no?
yeah.
It is a mixture. So basically, this lemon tea, some of us wants more lemon, and some of wants less lemon. The amount of lemon. Are you getting my point? So all I want to say is that in mixture, when two or more, just wait a minute, it's gonna be off. Are you able to see the screen?
Yes, sir.
See, when two or more substances combine together in any proportion, the mixture is not basically the proportion is not fixed according to our requirement or according to anything. That substance after mixing, that is called your mixture in any proportion. Like I took the example of lemon tea. Some of us will have more lemon and some of us will have less lemon according to their requirement. So this is your mixture. Is that clear? Have you heard of name, atom, molecule, compound? Are you aware of this term?
Yeah. Yes, sir.
Okay. So these are different things. Like in compound, you are going to mix element in a fixed proportion. There is a very large difference between mixture and compound, and which one of the main difference is that in mixture you can mix in any proportion, but in a compound to get a specific compound, you have to mix in a fixed proportion. See, if you are going to take lemon tea, whether you are going to mix more lemon or less lemon, it will be lemon tea, right?
Yeah.
But if for a specific compound, you have to mix the element in a fixed proportion. This is the biggest difference between mixture and lemon tea. So I hope this mixture is clear with you. What does this mixture? If you are going to mix anything in any proportion, okay, that is called mixture. And you know, one of the biggest difference between mixture and compound, you know what is the biggest difference? If you are going to get a mixture, the property of that mixture will be, let's say this is your lemon and this is your tea, then you are getting lemon tea. Or let's say this is your salt and this is your water, so this you are getting salt solution. Let's take another example, sugar plus water, then you are getting sugar solution. So what I want to say is that you can mix these two in any proportion, you will get this mixture only. Are you getting my point? In any proportion.
Yes,
Okay.
sir.
And the next difference between compound and mixture is that this product that we get after mixing will have the property of the constituent that it comes from. That means basically the lemon tea will have property same as lemon and tea. The salt solution will have same property as salt and water. Sugar solution will have same property as sugar and water. Are you getting my point?
Yes, sir.
Now, but if you are going to make water H2 plus O2, let's say it becomes H2O. H2O is a compound. Okay. Okay. First of all, to get water, this hydrogen and oxygen should be mixed in a fixed proportion, first of all. Okay. It is not like you can add any amount of water and any amount of hydrogen and oxygen and you will get water. You will get a different thing if you are going to mix this in different proportion. Is that clear?
Yes, sir.
And moreover, this product that you get after combining this reactant or this elements will have entirely different property than this these two. Are you getting my point?
Yes, sir.
So basically these are two main difference between mixture and compound. For mixture you can mix in any proportion, and the product after mixing that you are getting will have the same property as you mixed the both substances, will have the same property as this lemon or tea, salt or water, and sugar and water. Please do write it.
Okay. So I finished.
Very good. Now we are going to first see how many types of mixture are there on the basis of mixing. Now the mixture are of two types. One is your homogeneous mixture, and another is heterogeneous mixture. Okay. Now see what is homogeneous and what is heterogeneous. What do you think is the homogeneous mixture?
Heterogeneous. It's it's when you mix both substances or compounds like non-uniformly.
Non-uniformly or uniformly?
For heterogeneous, it's non-uniformly.
Uniform. And for homogeneous, it is uniformly. What does this uniformly and non-uniformly means to you? Can you
Uh,
give
it-
an example?
like, for example, when you're like mixing salt with the water, the salt dissolves with the water, so it becomes a uniform solution. Whereas for
Very good.
heterogeneous sand and water, it
Very good.
will
Very good.
sink water.
So we can write a very basic definition of this, and that is a mixture which is uniform throughout the throughout throughout. That is your homogeneous, and we can write for heterogeneous a basic definition of this: a mixture which is not uniform throughout, or not uniform, that is enough, is called heterogeneous mixture. Now I'm going to write a point about this. A mixture which has a mixture which has single phase. What does this single phase means? I will just explain. And here I can write a mixture which have more than one phase. More than one phase. So basically, what does single phase and more than one phase means to you? Simple, it's very simple. Like you told me that when you are going to mix salt in a water or sugar in a water, let's say salt plus water, what will happen after dissolving this salt in water? Will you be able to differentiate that where is salt and where is water? Will you be able to differentiate?
No.
No, not at all. Basically, it will be looking same throughout the solution from top to bottom. It will be same. You cannot differentiate that here is the salt if it is completely dissolved. It is completely dissolved. Are you getting my point?
Yes, sir.
That's why I wrote here has single phase. If you are going to mix milk or water in a milk, will you be able to differentiate that water is this here and milk is there? Will you be able to do that?
No.
So it looks like same. Basically, it will have single phase. Whereas you just give an example of sand plus water. Okay. Now, you know that it will have two phases. How it will have two phases? You know that when you are going to mix sand in water, it is not soluble. It will go and uh, what we say, it will be on
At
the
the
bottom.
bottom. Yeah.
At the bottom, you can easily say from this point to this point, sand is there. You can see two types. There are two phases in that solution, and hence it is heterogeneous mixture. Or either you can mix petrol, diesel, mustard oil. Like you can see now you will have three different phases. Water, which has the highest density, will be lower than your petrol, then your mustard oil, then your petrol. Are you getting my point?
Okay.
So this will have more than one phases, that is heterogeneous, and the one which have single phases, that is your
Heterogeneous.
homogeneous. Single phase, homogeneous; more than one phase, heterogeneous.
Okay.
Very simple.
So finished.
Very good. Now we are going to talk about solution. Just wait a minute. Do you know what is solution?
Solution is the mixture of two or more substances which is homogeneous.
Very good. Now I'm going to give you a perfect what we say definition, which is that you just told me. What is solution? So basically, solution is also a mixture which is mixed in a uniformly. Okay, is it possible that a solution can be in solid state? Is it possible? Yes or no? Basically, when we talk about solution, it's just like we think that the solution should be, or the solution is in liquid state. Yes or no?
Yeah, solution, yeah.
A solution is a homogeneous homogeneous
Mixture of
mixture
water.
of two or more substances. Now, you have heard of so are you aware that basically we think that whenever solution we hear or heard, we think that the its physical state will be liquid state, but it's not true. Solution can be in gaseous state. A solution can be in gaseous state as well as a solution can be in solid state. Are you getting my point? Now I'll give you some example. Like in gaseous state, solutions example will be air. Air is a homogeneous mixture of different gases.
Yeah.
Okay. Now, when you are going to talk about in solid state, alloys are basically mixture of different metals or non-metals. Okay. Are
Okay.
you getting my point? And you know that in solid liquid state, you know a lot of example, right?
Yeah.
You can take sugar plus water and lots of examples. So please do write this. And we can write for alloys. Very important. Alloys are, then I will explain, mixtures of two or more. Please do write up to this and then let me know.
Okay. So finished.
Very good. So are you finished with the alloy part as well?
Yeah.
So basically, what is alloy? You can see alloys are mixture of two or more metals or a metal and non-metal, and it cannot be separated into their components by physical method. Chemical method, with the help of chemical method, you can do that. Is that clear?
Yes, sir.
Okay. Now I'm going to write some properties of solution. A solution is a homogeneous mixture. Always remember this, you know that already. A solution is a homogeneous mixture. It is not heterogeneous mixture. The particle of a solution are smaller than 1 nanometer. 1 nanometer. It is smaller than 1 nanometer. That means 10 raised to the power minus 9 meters. Are you getting my point?
Yes, sir.
Just
So
wait a
can you hear?
minute. Yes, yes. Basically, your voice is lagging.
Oh, okay.
Now, see, the particle of a solution are smaller than 1 nanometer. You know what is nanometer? It is a unit of length, you can say. Okay.
Yeah.
So it is 10 raised to the power minus 9 meter. Now, what I want to say is that 10 raised to the power minus 9 meter in diameter. I think you are aware of diameter, right?
Yeah.
Can you tell me the relation between diameter and radius?
Radius is a distance. It's a distance between two objects, and diameter is like the surrounding of the object.
Can you tell me again?
Uh, Radius is like the distance between two objects, whereas the diameter is like the surrounding of the object.
Yeah, it's basically radius is equal to diameter by 2. Half of the diameter is called radius. Okay.
Yeah.
Yeah, this is what I want to know. So if the diameter is 10 raised to the power minus 9, will you be able to see it with your naked eyes?
No.
Yes or no?
No.
No, you cannot see. That's great. So cannot see, or we can write they cannot be seen by naked eyes. Okay.
Okay.
Now the next point about this solution is the solute particles cannot be separated. Solute particles. I will tell you about something which is solution. Solute particles cannot be separated from the mixture, which I already have written, mixture, by process of filtration. By process of filtration. Why we cannot do this? I will explain that. Please do write it.
Okay. So finished.
Very good. Now see, as you know that I told you that this is a solution is a homogeneous mixture. You know that the particle of a solution are smaller than 1 nanometer. That's why we are not able to see with naked eyes. Also, solute particles cannot be separated from the mixture by process of filtration because the solute particle size of solute particles are smaller. Is that clear?
Yes, sir.
We can also write the solute particles do not settle down when left undisturbed. When left undisturbed. And this means basically the solution is stable. The solution is stable. So basically, solute do not settle down when you are going to mix it and keep it somewhere safe. So it do not get settled. Is that clear?
Yes, sir.
Please do write it. There is another point, and that is because of very small size. Because of very small size. So right, because of very small particle size. They do not scatter a beam of light. passing through the solution. So that's why the path of light is invisible. The path of light is not visible in the solution. Please do write.
Sir,
Yes, yes.
I finished, sir.
Okay. Also, to scatter the beam of light, there is a minimum size. And if you are going to pass a beam of light through solution, it will not scatter the beam of light because of its small size, and hence the path of light is not visible in the solution. Is that clear? There are other properties like there are like solution, we have suspension, we have colloidal solution. They will scatter beam of light. Is that clear?
Yes, sir.
Now, what I wanted to tell you is about solution. Do you know how solution we prepared? Basically, in solution, what we do, we add solute in a solvent, then it becomes solution. Are you getting my point? Let's say if you are going to mix sugar into water, then it becomes sugar solution. Are you getting my point?
Yeah.
Now, can you tell me which one is solute and which one is solvent? How do you decide whether which one is solute and which one is solvent?
The sugar is solute, whereas the water solvent, because um,
Can you repeat?
the sugar is solute and water solvent.
Why did you choose sugar as solute and solvent, water as a solvent?
Because water is the main uh, compound for making
No.
solutions.
See, basically that is good. This is general that water is solvent in every case is almost okay. Now, focus here. The one which is more in quantity or greater in quantity, this is your Q quantity, that will be your solvent. Are you getting my point? And the one
So,
which is lesser in quantity,
Is solute.
is your solute. Please do write it.